Relations and function. This is the name of this lecture. It's a second lecture of the class 11th. We are going to explore this lecture in too much details. Whatever will be important, those topics will be covered in this. Uh, we will start with meaning of relation. Then you can say I am going to start from scratch till the advance. So without wasting time, let's start. Without wasting time, let's start. So in this slide, you saw that yes, this is our lecture, and it is a second lecture of 11th class. Now there is nothing. Don't worry. Here there is a mother, and there are two children of this mother. So can we say what is the relation of woman and these two children? We would say what? Mother and son, mother and daughter. These are relations. Here, relation of this is with this. Relation of this is with this, isn't it? No. Yes. Same here. We are saying here. We are saying 7 is greater than 3. 7 is greater than 3. So can we say that she is greater than these two children? Of course, yes. Here we know it is a very too much basic. 25 is equal to 5 raised to power 2. Here it can be written as a 3 is less than 7. Yes, we know that it can be written as 3 is less than 20, less than 7. This is less than 7. Here we can write it as a 25 is a square of a 5. Yes, we know 25 is a square of a 5. 25 is a perfect square. So yeah, this and this is a phrase of tense. So this is relations. Wow, these are relations. Okay, this is also relation. In mathematics, relation, meaning of this relation will be similar in mathematics. It will be important, it will be necessary to understand Cartesian, about Cartesian product, so that we can understand about a relation. After understanding a relation, we will learn about the function. So here we are going to start with the Cartesian product. This is a basic of the first lecture. If you are confident about this, then you will be able to understand the relation and function easily. But if you are not confident about this, then this is for you. You will have to watch here carefully. Pay attention carefully here. Cartesian product is what? Our learning objectives are ordered pair, ordered triplet, Cartesian product, and sets. Right? We have this learning objective. So ordered pairs and ordered triplets. Ordered pairs and ordered triplets. What is ordered pair and what is ordered triplets? So let's see. Ordered pair containing two objects. When we are saying ordered pair, so remember, something will contain two objects. Something will contain two objects in the case of a ordered pair, and it is written in parentheses. Okay, parenthesis. This is parenthesis. So we will write these two objects inside this by separating comma. This will be ordered pair. This whole will be ordered pair, like this open bracket, then 7 comma 2, then close bracket. This whole is ordered pair, one ordered pair. Here you can see we have two sets. One is A, this B. In this we have three members: Sumit, Amol, Aral. In this we have two objects. First is the Singh, second is the Kumar. Here either we can say Sumit Kumar, Sumit, Kumar. So we are writing it this as how Sumit, Kumar, Sumit, Kumar, and we applied this parenthesis. This whole is a ordered pair. This whole is a ordered pair. Okay. This whole is a ordered pair. Here we took two objects and we separated two objects by using comma, and those two objects are inside the parenthesis. This is what is a ordered pair. Clear? This was a definition of Sumit Kumar. Now we have Radha then Singh. Radha then Singh. We are saying relation of this is with this. Relation of this is with this. Then we will write Radha, Singh. Radha, Singh by using parenthesis. Radha, Singh. We can here you will see Radha, Singh. In this we have two objects, and these two objects are in this parenthesis just by separated these two objects by using this comma. Next we have Radha. We are saying Singh is a relation of a Singh is with Radha. First Singh will come, then Radha. So Singh, Radha. Singh, Radha. Till now we understood meaning of ordered pair. Till now we have understood meaning of ordered pair. Now next we have order is important. Order is important. Ordered pair. This is ordered pair. Ordered pair is equal to A, B. A, B are elements. A belongs to A set. A elements belongs to A set, and B belongs to B set. This is what is the meaning of this set builder form. Here we are saying there are two elements here, A, B. These are two elements in this, and we are saying this is such that A belongs to A. So A will be in set A and B will be in set B. This is what is the meaning of ordered pair. Here with example, let's say so we go to two sets. In first we have 1 2 3, and in second we have 5 6 7. Now here in this set we have 1 2 3. This is a Venn diagram. Ordered pairs are what? So ordered pairs of these two sets would be what? First of all, we will have to relate first to B or B to A. So here 1 is mapping to 5. 1 is related to 5. So we will write 1, 5 and surrounding by parenthesis. Here 1, 5. And here we can see first is belonging to A set and the second is belonging to B. Clear? Now next we are saying A is related to 6. That is what we are saying. So here now you can see 1 is belongs to A set and B belongs to B set, and that is how will be formed a ordered pair. Will be formed. Now next we have 1, 7. Now this relation of this is with this, also with this, and also with this. So how will we write? Just 2, 5, 2, 6, 2, 7 like that. Here these are ordered pairs. These are ordered pairs of these two sets. And we got this ordered pair just by relating one set to B set. There can be more. here 1 comma 5, then 1 comma, okay, 1 comma 5, then 2 comma 5, 5 comma 2, then 5 comma 3, then we are finding all order pairs of these two sets. All 5 comma 3, then 6 comma 1, 6 comma 2, 6 comma 3, 7 comma 1, 7 comma 2, 7 comma 3. All these are ordered pairs of these two sets. All these are, and we can also say that all these are subset of these two sets. This is a subset of this, and this is also subset of this. Difference between set and order pair. Difference between set and order pair. Hold on. Set and order pair. What's the difference between them? Let's see. This is set and this is order pair. What's the difference? Here we use a curly bracket, but here we are using parenthesis. This is what is a big difference. For representing set, we use this curly bracket, but for order pair, we only use this parenthesis. And here we know that A is not set. Here A is a set. A is a set. This A is showing what a set. Okay. Now next we have 2x comma y. In the case of a set, we can convert these elements. We can, here order will not matter. Here index will not matter in the case of a set, but in the case of a order pair, index will matter. Position of elements will matter. Here in this, position of elements will not matter, but in the case of order pair, position of elements will matter. This is what is a big difference. This is second big difference between them. Here in this, it will not be equal to. Now repeated elements are not written twice. Yes, in set repeated elements are coming, then this will be written only one time, but in this we can write too much time. Repeated elements, here x comma x is equal to this x. Here repeated elements are written twice. Here x comma x, then here this will not be equal to only one element. Here we should have two elements in this. Two elements. Okay, two elements. Now next, this set can have more than two elements. More than two elements. But as you can see, x comma y comma z. But this ordered pair will have only two elements. Only two elements, but it can have two or more elements. Cannot have more than two elements. Yes, it is a true. It is a true. Now next, x comma y z. No. This is not ordered pair. Ordered triplet. This is ordered triplet. If there are three elements and surrounded by parenthesis, will be triplet order. Ordered triplet. Equality of ordered pairs. Equality. Here we have a comma. This is order pair a1 comma b1. This is order pair. Same here we have what b is equal to a2 comma b2. Okay. Here a comma a1 and a2 both are different. A comma is equal to a2. A comma is also equal to b2. Example, find the value of x and y. So here we are saying this x and this x will be both equally 2 plus x, and y plus y 2 is equal to x, and here y is equal to minus 3. So here we have value of y as a minus 3 and value of x as a 2. This is what we are saying. Okay, now next, in this find the value of x and y. Just you will have to solve it. After solving this anyhow with method, you will get a value of y and value of x. Now we came to the Cartesian product. Let's see what is it. We have two sets. In this set is containing this much colors, and in this two objects, pen and pencil. So we are saying blue is related to pencil as well as to pen. So what will be blue comma pen, then blue comma pencil. This is order pair. Now we have red comma pen, red comma pencil. Okay, now black comma pen, black comma pencil. These are ordered pairs of this. So Cartesian product is what? Set of all possible ordered pairs. Whatever will be possible ordered pairs will be Cartesian product. All these are ordered pairs of this, and these ordered pairs are number of ordered pairs is a Cartesian product. So A multiple B. So here Cartesian product is written like that: A multiple B, then is equal to A should belongs to A and B should belongs to B set. B element should belongs to B elements. Let's see. Here we have. So this is belonging to this set, and this is belonging to this set. So pen comma blue. We now pen blue. Then here blue comma pencil, yes, just opposite. So red comma pencil, pen comma black. So black comma pencil, just opposite. Now all these are ordered pairs. Here what is happening? This A is belonging to A and B is belonging. Here you can see this pen belongs to this set, but blue belongs to this set. This blue belongs to this set, but the pencil belongs to this set. These are right. These are correct order pairs. B multiple A. Here B. Here we are saying B should belong to B A set and A should belong to A set. Here as you can see, we got this sets 1 2 3 B. Now what will be Cartesian product of these sets? Just A multiple B. In this case we will take what? 1 comma 5, then 1 comma 6, 1 comma 7, then 2 comma 5, 2 comma 6, 2 comma 7, then 3 comma 5, 3 comma 6, 3 comma 7. Now what about this? This would be what? Just opposite. 5 comma 1, then 5 comma 2, 5 comma 3, then 6 comma 1, 6 comma 2, 6 comma 3, 7 comma 1, 7 comma 2, 7 comma 3. This is what will happen. Here you can see these are order pairs. Here so Cartesian product of these sets A to B will be what? These orders, and Cartesian product of B multiple A would be this order. If G is this, G is what? 7 comma 8, and H is what? 5 comma 4. Here G is a set, okay, H is a set. So find the Cartesian product of a G and H, then H, then Cartesian product of a H multiple G. So we are able to find. So first let's say this G multiple H. So for this we will start from here 7 comma 5 7 comma 4 7 comma 2 8 comma 5 8 comma 4 8 comma 2. This is a order. These are ordered pairs of this G multiple H. Now what about this H multiple? We will start from here 5 comma 7 5 comma 8 then 4 comma 7 4 comma 8 then 2 comma 7 then 2 comma 8. Here you can see. Okay, I hope you are able ready for challenge. If A multiple B, okay, find A and B. Oh, we know that all these x values are of A set, first set, and second y values are set of second. Here you can see. I can say confidently that A, then B, R, but here we are forming a set. So here in a set would be what A comma B. In a set would be what x comma y. Here x comma y. So here A is belonging to x and B is belonging to y. Now Cartesian product of this would be what A comma same this A comma x A comma y. Yeah. Okay. And then A comma y. A comma x then A comma y. Then B comma x then B comma y. Important points about Cartesian product. We have this A is equal to 5 null. It is saying that we have important points. This is what empty. In this set we don't have any elements, and in this set we have two elements. So here it is saying that A set has infinity sets, but in this we have two sets. So number of this A set is how much? Number of elements of this set is how much? 2? No, not at all. Here A is what? A is 1 comma 2 and B is 3 comma 4. So Cartesian product of this would be this orders and this orders. So 1 comma 3 3 comma 1. Here you can see both both are not same. So we can say both are not same, that's why we can say this will not be equal to this. Anyhow, if A or B is a null set, then so A multiple B would be what? No, nothing. It will not make order pair. So A multiple B is equal to null. If A or B, so Cartesian product of this would be what? Nothing, just 3 comma 4. Nothing. A or B is a infinite set, then so A multiple B would be what? Infinite. So I think no, infinite. Yes, infinite. If a number of A elements is a P and number of B elements is a Q, then in this case we will multiply this by this. Then what will happen? Root is a 6. Hold on. Here what is happening? In this we have this 2 elements, this 3 elements. So in this we have 2 multiple 5. So 3 plus 5, 3 plus 3, 3 plus 3. relation 3 multiple 2 would be 6. So let A any set this A multiple A multiple A. These are sets. All these sets are containing this same. So here we can say A is belonging to A set, B is also belonging to B set, A set, and C is also belonging to A set. This is what we can say. Now next we have ordered template. Here ordered template is a coordinate which has 3 elements in this, surrounded by parentheses. If A is equal to this minus 1 comma 1, then Cartesian product of this A multiple A would be what? Minus 1 comma 1, then it would be what? Minus 1 comma minus 1, then minus 1 comma 1, like that. Let's see here. First of all, minus 1 comma minus 1, then minus 1 comma minus 1 comma 1, minus 1 comma minus here, minus 1 comma minus 1 comma 1, minus 1 comma minus 1 comma minus 1, 1 comma 1 comma 1, like that. Here you can see all these are ordered pairs. These are ordered template. The Cartesian product A multiple A has no elements. Yes. Among which are found minus 1 comma 0, minus 1 comma 0 and 0 comma 1. Find the set A and the remaining elements A multiple A, and the remaining elements A comma A comma A remaining element. We have got this number of elements, 2 elements. Now we are saying there are total how much? 9 elements of this. So apart from this, we will left how much? 7 more elements. 7 more elements. A multiple A is what? First set has what? Minus 1 comma 0, and both sets has what? Minus 1 comma 0. Not minus 1 comma 0, minus 1 comma 1 comma 0. Here like that, minus 1 comma minus 1, then 0 comma minus 1, then 0 comma 0, then 0 comma 1. This is a relation. Let's see what is relation. We will link the discussion of what we studied. Cartesian product. So we will link Cartesian product, discussion of a Cartesian product with a relation. Let's see. Learning objectives. What is a relation? How to represent relations. These are learning. What is a relation? What is the meaning of relation, and how to represent this relation. So I think what is a relation? Here we have 2 sets. In each set what is happening over here? Let A is equal to 1 comma 2 comma 3 and B 4 comma 5. Define a relation from A to B. Okay, relation from A to B. So we will define like that: 1 comma 4, 2 comma 5, like that. So here it is saying relation is equal A comma B. This should be ordered here, and such that b is equal to a plus 2. So whatever you will get a, just add with a, then you will get b. And here a should belongs to a set and b should belongs to b set. So here if we will take 1, then if we add 2, then here would be 4. Then next, if we take 2, then we add 2 more, then again we are getting 4. If we get 3, then add 2, then we are getting 5. These are orders. Let's see. So okay, first of all 1, then we will get 1, okay, 1, then 1 plus 2 3, then 2, then 2 plus 4, then 2 3 3 plus 2. Yes, first of all 2 comma 4, 1 comma 3, there is no 3 in this. So 2 comma 4 and 3 comma 5, these are relations. 2 comma 5. So Cartesian product, this is Cartesian product, but it is not relation. This is Cartesian product. Cartesian product will give you all the possible order pair, but relation will not give all the order pair. Relation will give whatever is the relation of A with B, so that will be relation. So clearly R relation is what? It is a subset of A multiplying. Yes, this is a subset of this. Relation is a subset of this Cartesian product of a set. Yes, we know that a relation is a subset of a set. Now next, let A is equal to 1 comma 2 comma then 14. Define a relation R from A to A by R. R relation is that x comma y are elements, and here 3x minus y is equal to, it should be equal to 0, where x comma y should belongs to A. Write down its domain and range. So here we are we have this much. In this, what is happening? R is equal to x comma y, okay, and x y should belongs to A. So here if we put 1 and here 2, so 3 minus 1, 3 minus 2, 3 minus 2 is what? 3. Then what will be 3? So minus 3. If we put here minus 3, x as a 1, if we put 1 here, then we will get 3. If we put here 2, then we will get 6 as a y. If we put here 3, then we will get 9, then 4, then 14, then 5, then 15. But it is not belonging to A. 15 is not in this. So we have this much order pairs. These are relations: A 1 comma 3, 2 comma 6, 3 comma 9, 4 comma 12. These are relation. This is the relation. One comma 3, yeah, this is relation. So in this Question is also saying find the domain and codomain and range. So in this case, we can see domain of this our relationship. We have this all these x values, all x values will be domain, and uh, all y values will be codomain, But when it will come to range, so range will be output of input. Range will be output of input. So in this you can see domain of R is this x values 1 2 3 4, and common codomain will be what, just y values, okay, all y values. But whatever we go to output after entering input, these are inputs, and when we enter this input, then we got this output. So this would be range, not all from 1 to 14. From 1 to 14, this all will be codomain. But whatever we got output as a result will be range, okay, will be range. So range is just output of input 3 comma 6 comma 9 comma 12. Okay. Important points and representation of a relation. Important points about relations and how to represent the relation. That's it. So representation of a relation is possible using two ways. First, algebraical representation, and second is visual representation. That's it. See both. First is cell builder form, and second is roster form. We have seen this in the lecture of set, but again we will repeat this. And visualizations through Venn diagram, we can represent this relation. Arrow diagram, not a Venn diagram. So there are two sets, okay. Then first we can see relation elements of A are the square of elements of A are the square of elements of B. This is a statement representation in roster form. Let's see. So roster form will be clear visible here 9,3, 6,4, 25,5. These are clear visible. But when it will come to set builder form, then you will have to understand carefully. You should have to pay attention carefully on this set builder form. Here it is saying x comma y are, this is order pair. It should be order pair such that x is the square of y. X is the square of y, and x should belongs to A and y should belongs to B, other side. So here x is the square of y. X is the square of y. So it is started from 3. Here 3, then 4, then 5. So first will come what? 9, because it is a square of this is a square of 3. This is a square of 3. So 9,3, then 60,4, then 25,5. So meaning of this is in set builder form and this is in roster form. Meaning of both are same. What is the arrow diagram? Just like that. We will say that the relation of a set is to be like that. Here with the diagram we are saying that a relation of this is with this, a relation of this is with this, a relation of this is with this. That is what we are saying just by using this arrow diagram with the help of a Venn diagram. Now we have this 2 raised to power pq. Number of relations possible from set O to B. We know any relation for set A to set B. Any relation for set A to set B is a subset. Of A multiple B. So here any relation for set A to B, for any relation for set A to set B is a subset of A multiple B. If you are taking a relation, it means your relation is a subset of a set of a Cartesian product, of a Cartesian product. So any relation for set A to B is a subset of A multiple B. So number of relation is equal to number of subsets. Number of relations is equal to number of relations is equal to number of subsets of a Cartesian product of sets. Even I didn't understand, don't worry. Power set of A multiple B. All subsets of Cartesian product would be what? Power set of A, this Cartesian product. Here number of this first set is this P and number of this second set is a Q. For any set, this is number of a set. We will see this later. To find out all ordered pairs, we will have to write this 2 and number of elements. Number of elements. One ordered will be one element. So whatever are numbers of elements, just write here, and 2 will be as it. Then 2 raised to power is something. Then you simplify that. You will be your this will be your answer. Now next we have let A this set has x comma y comma z. Okay, this is 1 2 3. Find the number of relations from A to B. From A to B, it can be x comma 1 and y comma 2, x comma 1 and y comma 2, or x comma not x, yes, with the help of we now number of relation is equal to number of subsets of this. So here, okay, this is what, this is a Cartesian product. So here we now this is 3 and this is 2. So number of elements in this we have 6, and same this will give us not 6. Number of relations is how much? Number of relations would be this much. Ready for challenge? Determine the domain and range of the relation are defined by this. We have this in a set builder form. First of all, we will have to simplify it. Then we will have to find the domain. Then we will have to find range of this set builder form. So here it is saying x comma x plus 5 plus 5. This is what is order pair, and it should be, it is such that this is such that x should belongs to this, x should belongs to this. It is saying the 0 x as a 0, first of all 0 comma 0 comma what 0 comma 5, 0 comma 5, then 1 comma 6, then 1 comma 7, 1 comma 8, 1 comma 9, 1 comma 10. Not 1 comma 10, brother. First of all 0 comma 1, now 0 comma 5, then 1 comma 6, then 2 comma 7, then 3 comma 8, then 4 comma 9, then 5 comma 5 comma 10, like that. These are relations. So roster form would be what? 0 comma 5, 1 comma 6, 2 comma 7. This is in roster form. So relation would be what? Remember, input should be unique. Output can be many types. 0, 1, 2, 3, 4, 5. So these are uniques. These are uniques. Now, so all these are what relations? Domain. Here domain would be what? This is a relation. So domain would be what? This is 0. X values are domain. And rest would be what? All these y values. All these are output of this x value. Here 5, 6, 7, 8, 9, 10. Codomain, same codomain. Here codomain is equal to range of a relation. Now we came to the function topic. We came to the function topic. What is a function? There is a connection of a relation with this function. Our learning objectives here is what is a function, how to represent, this, how to represent this. Hold on, somebody is calling. Who can this? Wow. Let me decrease this sound. Here we have this learning objectives of this function. What is a function? How to represent functions and types. We will see how to represent function and the types of a function. We will see how to understand functions, real functions on graph. What is algebra for real function? All this will be covered in this. Don't worry. Now we are starting with the meaning of a function. Function is also a relation. Yes, this is relation from A to B. But remember B to A. Yes, from A to B. Only if it follows to a specific rule. But all inputs should give output. All inputs of a set of one set should give outputs, and inputs should not be same. Here those two specific rules are: every element of a set A, every element of a set A should have an image in set B. Yes, every element of a set A should have only one image of A. It is talking about of a set of A. So every element of a set A should have only one image. Every element of a set B can have more images, but first set should have which is giving input, which are taking input, should have only one image. So every element of a set A should have only one image in set B. So 2, 6, 8. In this set we have this 2, 6, 8. So what is happening here? You can see all this are only one image. This 2 is only one time, this 6 is only one time, this 8 is only one time. These are inputs and this would be output. This can be many times, this image can be many times in this, but here it should be only one time. Now we can say relation of this is we can relate this with this, we can relate this with this. Okay, we can also relate this with this. Here this with this with this, and this with this. So if we are entering 2, so it is a giving 14. 6, there is no relation of a 6 with any elements of this set, it will not be function. So rule 1, it is not following. Every inputs is not giving outputs. Here you can see. Where is the output of this 6 input? No. That's why this one rule is not completed in this. Now what if here second rule is what? Only one input is giving two solution, but it is not possible in this in function. So only one put should give only one image. Only one put should give only one image. Here too. So this is also invalid. Every element of a set A should have only one image in set B. So here this element has two images of this set, which is not valid in this. Not a function, because of two rules are not completed in this. One rule is that there is no relation of this with this element, and second is that each one element is containing two outputs, which is not possible in function. Only one output will give only one input will give one output. Example tools here you can see each inputs are giving outputs. Yeah, we can see one is completed. Now next we have second. What is happening here? Each element of a set has one image, one output in set B. This is completed in this. So this it's a function. Yeah. Later to sets A is equal to 9, 16, 25. 9, 16, 25. Here we have a square of 3. 3 is a 9 and a square of a 4. A square of a 5. Here you can see. So function of this would be what? We can easily say 9, 3 to 9, 4 to 16 and 5 to 25. But from here we are going. So in this we can see, okay, output function. If function will be represented by just a small e, this would be function is equal to x comma y. It is what ordered pair, it should be ordered pair such that y is equal to x inside the under root, and x belongs to a and y belongs to b. This one will belong to a and this will belong to under root of x. If there is a 3, this is 3, 9. So what would be 3? Y would be 3. Y would be 3. So can we say 3 comma 3, 4 comma 4, then 5 comma 5. 3 comma, okay. Yeah, but when we put x, then of course it will give us 3. Only covered elements of a set B. Yes, this range, these are range 3, 4, 5. This is range, but 2 is not range. 2 is a codomain. All these are codomains, but 3, 4, 5 will be range because 3, 4, 5 are outputs. 3, 4, 5. How to represent functions and types of a function. Representation of a function. Representation of a function if such that a set is belonging to set B. A set is belonging to set B. In this case, A set, this whole elements of a set A would be domain and whole elements of a set would be codomain. But output would be range. Remember, here we are saying function such that this is a function a to b. So if we are saying that this is a function, so of course this would be also range, this would be also codomain. Clear? So meaning of this is what? If x value of x is something, for example 3, then we will put in place of x how much? 3. Here x comma y, and here this x is independent, not dependent. Y will be depend on x. Y will be depend on x. This y. When x will get input, then y will give output. Remember, x will be input, so x is independent. When x will take input, then y will give y will get what? Output from the input. So that's why we are saying x is independent and y is dependent. Now this is restricted. So f is what? Function. So here we are saying x we are saying x is the input. We are entering input in function to function. Okay, now we are entering input in this function, and this function, after input this after entering this x as an input in this, this will give us output. So output would be y, input would be x, and y would be output. Remember, next we have if this function z to j. So if this x is equal to x minus 1, then find 0. So here we have this what? This x, this x, this x. First of all 0, we will put here 0. So 0 minus 1 minus 1. So this whole will become 0. So y will come as a 0, then 1, then 1 minus 1, 0, then again 0, 0. Y is coming as a 0, then again 2, then 2 comma minus 1. So here we are getting 2, here 2 we are getting. First 0, then 0, then 2. These are values of these are outputs. These are values of a y. Here this 0 we got as a output, again here. All these are y and all these are x. These are inputs that we entered in this and we got output as a result. So types of a function. First is a identity function, and then next we have constant function, then we have polynomial functions, then we have rational functions, then we have modulus function, then we have signum functions, then we have greatest integer function. All this will be covered. All this will. So let's start with identity function. Do you have any problem? Let's start with the identity function. So identity function says that I will give a linear line. I will give a linear line. Identity function says. Here what is happening? We are getting x is equal to y. If x is 1, then y will be also 1. This is what is happening in this. So identity is what? X will be equal to y. This is what? If x is equal to y, then we can easily say that we will get a linear line. We are getting linear line because of x is equal to y. That's all. X is equal to y. That's all. So this type of a function will be identity. Now definition is what? If this is function r to r by y is equal to what? Fx. So both values of both are equally. Now domain would be range. This domain is r and range is also r. Graph would be what? This straight line and passes through the origin. Here meaning of this is what? If x is a 2, so y is also 2. If x is a 4, so y is also 4. If x is a 6, if we take x as a 6, then y we will get as a 6. This is happening and this is happening. It means we are getting a straight line. if we are getting straight line, it means this is what this whole process is talking about identity function. This is a function, but which kind of a function? Identity function. Now next we have constant function. Constant function, which means something is not moving. Okay, something is not moving. uh, let's explore this. Here, constant function definition, we have this. Okay, if this is function to r by y is what this, and it is a constant. Whatever we put in ix, we will get constant. Let's see where c is a constant for each. R belongs to r related to x. Domain is what r. This r is a whole domain, and range is what c, constant. What is happening here? If we will take 2, then we will get what? Y as a same. If we put x, then same here. Same we are getting y same value 4. Again, if we are putting x different number, but we are getting y 0, not 0, same value. So this, if we put x different number, but y is coming same again and again. So here we can say y is a constant. Here we can say y is a fixed. Y is not moving. X is moving. X is changing its value, but y is not changing its value. So this is a type of. So here we can say, what can we say, that y is not moving. If y is not moving, so this type of a function is what? Constant function. Constant function. So a straight line, yes, a straight line, but this is a parallel to x-axis. In this case, this is also straight line, but it is a passing through the origin. In this case, this is a straight line, but we cannot say both are same, because in this, what is happening? This straight line is parallel to x-axis, but in this is not parallel to x-axis. Clear? Now next we have polynomial functions. Polynomial function graph will look like this. In this, what is happening? Okay, y is equal to this, and if we get this, first of all 1, then this, then plus a2 x square, a2 x, where n is a non-negative integer, a0, a1, a2, and an. So x raised to power 3, x raised to power 3, polynomial function. This is what? X raised to power 3. And this is what? X raised to power 2. And this, what is happening? X is what? 2. So y is also 2. X is 2, then y is 4. If we put here 2, then we will get y as a 4. Then again we put here, this is at 2, then we will get 4. So it will look like that. But in this case, if we put here 1, then it will come here over. Then 2. If we put here 2, this is 2. So what will be y? Y will be 2, 2 is 4, 8. Here, this is coming over here. This x is 2, so y is coming. So it will look like that. So what is it talking? It is saying that if you put input 2, then you will get output how much? 8. Same opposite. And it is a figure of a cubic function. This is figure of a quadratic function. Quadratic function. Here what is happening? If you put here 1, so it is 0. From 2. If you put here 1, then this wall will become 1. If you put here 2, x2. So y is how much? 4 here, over here. If we put here 3, so it will be how much? 9. Y will be how much? 9. Y will be output, which is 9 here, over here. It is going like that, and this is a rational function. It will look like that, rational function. I will talk about in details in separate lecture. Here we have 1 upon x. If you put 1 here, then what will happen? We will get 1, y as a 1. If we put here 2, we will get 1 upon 2. If we put 3, then we will get 1 upon 4. It will be close to the 0. It will start from 1 till the approximately to 0, but not exact 0. Modulus function looks like that. We have this is signum function, then greatest integer function. Modulus function is saying if r belongs to r by if x is equal to x. Here, if we have x as a -3 integer number, then it will be positive in modulus. It will be positive. For example, here x is what? X is how much? 3, -3. So x here we have -4. So it will become 4. So this 4 is what? Y. This 4 is a y here. It is over here. 4, 4. And if we put here only 4, so this is 4 here, and it will be as it 4. Just a minus will be converted into positive by using modulus. So this type of diagram is a modulus function. In this, what happens? Just negative sign is converted into positive, and positive will be as it. It is done so that we can get a modulus function figure on graph. Are you crystal clear? Now, next we have signum function. Signum function. Here, meaning of this is what? Meaning of this is that if we take any number, and that is coming between integers, then that will be equal to y, but it would be not a fraction, but it would be integer as integer. For example, here we have this is one, not one. Here we have what? This one. So 1 would be 1 as it, this is 2 as it, and this is 3 as it. This is first. But in this what is happening here? It is starting from y, and y is 1. X is changing, but y is not changing. If this is minus 1, y is not changing, but x is changing. In this greatest integer function, there is a connection of this greatest integer function with this signum function. it is what, minus 1. For minus 1, it is equal to this, x is equal to minus 1 and less than 0, greater than 0, less than 0, means between 0 and minus 1. Whatever number is coming between 0 and minus 1 will be greatest integer function, and 0 between 0 and 1, but 0 including 0 including 0, so between this will be greatest integer function, and between 1 and 2 including 1 and excluding 2 would be what, greatest integer function, greatest integer function. It will happen with all integer numbers in this. We have more. What the hell? 66. Now next we have algebra for real functions. Real functions. We will see this later. Okay, this is for you as a homework. Now I hope we are crystal clear about this.